Hi guys, this is a review for the last quiz, quiz 9 for stats. Okay guys, so the first question on the quiz asks you for something called EBM. What the heck is EBM? That's error bound margin. They tell you to find whatever that is using the t-distribution where a sample size is 25, a sample mean is 6.25, and a sample standard deviation, deviation equals 1.02. Assume a 98% confidence level. So what the heck is this error bound margin? That's what it stands for. It's that T alpha over 2 times the sample standard deviation over the square root of n, you guys. So they tell you to use the t-distribution, so that's what we're going to do. We're going to use this t-distribution, which I labeled as t-distribution as an attachment. Okay, guys? So first thing we got to do when we use that table is find out what this thing called degrees of freedom is. That's just a sample size minus 1, so that's 25 minus 1, so that's equal to 24. They tell you that it's a 98% confidence level, so what you do is you go to the 98% confidence column and you go down to a degrees of freedom of 24, and I think you get 2.492 from the table. So make sure you see where I got that. I went to degrees of freedom 24, 98% confidence level, where they intersect. I got 2.492. So now guess what, guys? It's just plug in time. So it's T alpha over 2, which is 2.492. Sample S is the sample standard deviation, which is 1.02. And N is the sample size, square root of 25. So if you plug that, guys, into your calculator, you get 0.508. Okay, the number 2 says it's about a newspaper. 42% say they read the paper. Okay, assume conditions are met for a normal model for sample proportions. In other words, use Z normal distribution. Okay, guys. So they give us something called our margin error equals 0.15. Margin of, I think it's margin of error. Okay, guys. Based on this info, we can be 95% confident that the actual population who read the paper is in what interval. So we want 95% confidence level. We want a confidence interval. So confidence interval, guys, it's just a range of numbers. That's all it is. So this is something new in this section. We're dealing with something that we call proportions, which is basically just a percent. It's a percentage that meets a certain condition. So in this case, our proportion, 42% of the people read the paper. So you consider that 42% to be a proportion. Think of it as 42 out of 100 people read the paper. So we have this thing called the sample proportion, because we took a sample, I guess, and they designate it as p hat. Okay, so p hat is the proportion. So what is it? It's 42%. If we convert 42% to a decimal, it's 42 divided by 100 is 0.42. So our proportion of people that read the paper is 0.42. Okay. To find the confidence interval, it's not bad, you guys. You have to do p hat minus margin of error, p hat plus margin of error. So guess what? I think we have both of these. We have p hat, that's 0.42, minus the margin of error, they gave it to us. Where is it? 0.15. And it's 0.42 plus 0.15. Not bad. Okay, guys? So you do that on your calculator, you get 0.27, comma 0.57. That's it. So you just got to take the proportion, the 42% converted to a decimal, plus the error, or minus the error, plus the error to get that range of numbers. Okay? So the second one, not bad at all, you guys. Number 3, let's see. It's very similar to this, just different numbers. So for number 3, we took a sample of 100 kids, or 500. 500 students. 300 say they have jobs. Okay, assume conditions are met for a normal mode for sample proportions. And we want calculate. Ooh, I can't spell calculate, you guys know what I mean. 98% confidence interval. Okay, so first off, this is dealing with p hat. Okay, so p hat, in this case, what proportion of the kids have jobs? 300 out of 500 have jobs, right? So your p hat is that 300 divided by 500, which is 0.6. I think you can do that in your calculator, you guys. All right, we're going to need something called q hat. And that's just 1 minus p hat. It's going to be the formula I'm going to give you in a second. So you got to do 1 minus 0.6 equals 0.4. Okay? For 98% confidence level, we're using the Z. You want to take out that table I gave you for confidence levels, Z-scores on confidence levels. It's this thing, I think you'll see it as one of your attachments. So this says 98%, so 98% Z alpha over 2 is 2.33. So I got that right off this table, guys, okay? All right, so why am I doing all this? Because there's a formula. The formula for the confidence interval is p hat minus Z alpha over 2 times, oh no, it looks bad. It's p hat q hat over n, square root of p hat q hat over n, okay? And then guess what? For the high end, you just plus it, okay? So it's comma p hat minus Z alpha over 2 times the big square root p hat q hat over n, okay? So it's, I think we're just at plug-in time at this point, guys. So it's p hat. So p hat, what is p hat? 0.6. 0.6 minus, what's Z alpha over 2? 2.33 times big square root. P hat is 0.6. Q hat is 0.4. N is 500, right? Because that's how many kids you looked at, right? And then you got to do 0.6 plus 2.33 big square root 0.6 times 0.4 over 500. Okay, so you got to take out your calculator and do some work. Okay, so what I got is 0.6 minus 2.33 for that thing in the square root sign. I got 0.0219. Plus 2.33. And so now you got to take your calculator out, do that, subtract, add. So I got 0.567, comma, 0.633. That's it. Okay, guys, so for this last one, you have to first figure out what the p hat is proportion. Then you got to figure out q hat by just doing 1 minus that. Then you got to find the Z alpha over 2 by going to that little table because we know we had 98%. And then you got to write down this formula and just plug in all the numbers and do all the math and get the answers. So, I mean, if you guys make little math mistakes, I'm not going to take a lot off, so don't freak out over that. Okay, so give it a shot. Watch this a few times. Stop it. See what I'm doing. I just changed the numbers. Ask me. Come to the Zoom meetings. Okay, guys? All right. See ya.